a student, like few more students are there. Please let me know. Abdul Rahman Muhammad, please let me know. Quadrilateral, this chapter is just started or you have covered some portions from here? Don't know? Okay. So let's start with the quadrilateral. If you are not having the idea about quadrilateral, then just give me a moment. Okay. Let's start with the discussion about quadrilateral family tree. Okay. Now, after this one, we will be taking the theorems and everything. We will start discussing about that. So, just can you see my screen? Can you see my screen?
Yes, ma'am.
Okay. So let's discuss what exactly is quadrilateral family tree. Okay. So you must have created your own family tree, like when you were in lower grade. Maybe you have created your own family tree where the first member will be the like eldest member in your family, like your grandfather or anyone. Then accordingly you have created the family tree. Here we are having quadrilaterals family tree. What exactly is the meaning of this quadrilaterals family tree? Here you can see the eldest member of this family is quadrilateral. Okay, so whatever property or whatever quality this quadrilateral will be having. Okay, so whatever quality or we can say whatever property will be applicable for this quadrilateral, each and every other member of the family will also have that property. Okay, apart from that, each and every other member of the family must be having their own particular quality, but the quality of quadrilateral will be followed by every member of this family tree. So the first property of the quadrilateral, as the name says, it's a polygon having four sides.
Ma'am,
So as you can see, yeah, anyone saying
ma'am, we
anything?
started the exercise and we are on question number 7.
Okay, so yeah, that's what I was asking, whether we will be starting with the exercise or you have not started it yet. Let me start with the question number
No,
7
ma'am,
then.
we started the exercise and we were on question number 8 or 9. Yeah.
Okay, let me check. Okay, so I believe, just a moment, let me check. Okay, let's start with question number 9. Here the question says in parallelogram, ABCD, 2 points P and Q are taken on diagonal BD such that DP is equals to BQ. Show that first part, triangle APD is congruent with triangle CQD. The next part is AP is equals to CQ After that, we are having triangle AQB is congruent to triangle CPD. Fourth part is also there. AQ is equals to CP, and fifth part is also there. That is APCQ is a parallelogram. Let's do it. Let me draw the figure which is already given in the question itself. A, B, C, E. So here the question says in a parallelogram ABCD. ABCD is a parallelogram. So obviously one thing we know about the parallelogram, that opposite side will be parallel and will be equals to each other. So since it's a parallelogram, we can write it here that AD must be parallel to BC, and also AD and BC must be of same length. Apart from that, we will also be having AB must be parallel to CD, and AB and CD must be of same length. Right? That's the property of parallelogram. Now, where 2 points P and Q are taken on the diagonal BD such that DP is equals to BQ. It is also given over here that DP, this DP and this BQ are same. Now what we have to prove for the first part, APD is congruent with triangle APD and triangle CQB are congruent. So if you will focus on triangle APD, this is our triangle APD. And this is our triangle CQB. We have to prove that these two triangles are congruent. So let's see what exactly we are having the information in hand. So as now only we have listed it down that it's a parallelogram. So opposite side will be parallel and will be equals to each other. So we know side AD and side BC are same length, right? We also know that DP and BQ are same, which is given in the question itself. DP and BQ are, so one of the side from there and one of the side from here are same, already given in the question itself. So two information we got. Now to prove this two triangle as a congruent triangle, we need at least three information. And what are those? Like as we know, the congruency criteria is side 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 congruency, side congruency, angle side angle congruency, angle side congruency, and RHS congruency. So from here any one of the criteria must be followed, then only we can say it's a congruent triangle. So we are having here AD is equals to BC. We also have DP is equals to BQ, that is given in the question itself. Now what else we are having? So since AD and BC are parallel, since this line and this line is parallel, can we say this looks like a transversal, and we can say this angle and this angle will be the pair of alternate interior angle? This angle and this angle will be the pair of alternate interior angle. Let's see whether it is working or not. After taking that, this two angle, are we able to get any criteria? Like which criteria is getting fulfilled from here? So if we will be saying, we are going to write it over here that angle B QBC is equals to angle ADP. Since these are pair of alternate interior angle, you have to write it carefully in your copy, like in like proper way you have to write it in your copy that AD is parallel to BC, where BD is a transversal, hence QBC and PDC is a pair of alternate interior angle. Okay, now let's check whether which criteria is getting fulfilled. So for checking which criteria is getting fulfilled, just focus on one of the triangle, any one of the triangle, either the upper one or the lower one. Just focus on one of the triangle and see which criteria is getting fulfilled. So here we have used this angle, we have used this side, and we have used this side also. So it's clearly visible over here, the side angle side congruency criteria. By side angle side congruency criteria, we can say these two triangles are congruent with each other, right? So first part, we are done with the first part. Is it clear? Is it clear to everyone? Okay, let's move to the next part.
Yes,
Here,
ma'am.
the next part says AP is equals to CQ. Since the already we have proved that triangle APD and triangle CQB both are congruent, from here are corresponding part of the congruent triangle. Hence, both the side will also be same. By CPCT only we will be able to say that second part is done. Now let's move to the third part. Now next part says AQB and CPD. AQB and CPD, again we have to prove the congruency. Now let's see how can we prove so. So we are now going to focus on, let me color it. Now we are going to focus on this part, this triangle and this triangle. Let's see what we know. Here we know A, B, C, D both are same since it's a parallelogram. Okay. Now here we also know that BQ and DP are same because it is given in the question itself. As you can see here, TP, BQ are same. It is given in the question itself. So two side we have already got. What about the third side? Are we having one more side same, or just like the previous triangle, here also we are getting the pair of alternate interior angle? So if you will take this two side and this one as a transversal, this angle and this angle will be same. So we can say angle DPC, this angle and this angle will be same. So again we got side, angle and side. SAS criteria says that the blue triangle on the left side and the blue triangle on the right side both are congruent with each other. If you are not getting, please tell me. I'll be writing the whole steps also. Anyone having any confusion over here? No confusion? Okay, let's move ahead. So we will be getting this two triangle are congruent again by side angle side congruency criteria. Again I am repeating what information we have used. We have used that opposite side of a parallelogram are equal. We have also used that opposite side of a parallelogram are parallel. Now by the parallel condition we have got a pair of alternate interior angle. This one also we have used. And what else we have used? The given information, that is dp is equals to bq, that also we have used. And by taking all the information we realize that it is following the pattern of side angle side, and hence both the triangle are congruent with each other. Now the next part, AQ is equals to CP. So from here only we can say AQ, and from here only we can say CP. Both are congruent by what? By CPCT. Got it? Now the last part says show that APCQ it's a parallelogram. So we can say that already in the first part we have proved that triangle APD is congruent with triangle CQB. In the third part we have proved that triangle AQB is congruent with triangle CPD. Okay, without even taking first and third part, if you will be taking the second and fourth part, in second part we have proved AP is equals to CQ, of course by CPCT from the above one only. And in the fourth part we have proved AQ is equals to CP. Let's mark it. AP and CQ are same. AP and CQ are same. That's what we have already proved. AP and CQ are same length. We have also proved in the fourth part that AQ and CP are same. So if opposite sides are same, then obviously it's a parallelogram. So we will be saying AP is equals to, we will be saying that AP is equals to CQ, already proved. AQ is equals to CP, again already proved. Therefore APCQ, yeah, is a parallelogram. That's it. Clear? Is it clear to everyone? Please do ask if you are having any doubt over here. Is it clear?
Yes, ma'am.
Let's move. Okay. Let's move ahead. Next question says ABCD is a parallelogram. And AP and CQ are perpendicular. From vertices A and C, as you can see on the diagonal BD, we have to show that triangle APB is congruent with triangle CQD. AP and CQ are same. Let's see how to prove these two triangles are congruent with each other. One information we are already having in hand, that is ABCD is a parallelogram. So opposite side will be parallel and will be equal. Since ABCD is a parallelogram, we can say AB must be parallel to CD, and also we can say AB and CD must be same. And we can also say AD must be parallel to BC, and we can also say AD and BC has to be same. Now let's see how to prove the congruency. So we are talking about which two triangle APB. A, where is P? Let me mark P properly first. This is P and this is Q. Okay, so we have to prove triangle APB, this triangle. And triangle CQD. We have to prove that these two are congruent with each other. Now let's see which congruency criteria will get fulfilled over here and what information we are having in hand. Okay, so here we know one thing. We already know that AB and CD are same. Okay, one more thing we know, since ABCD are parallel, uh, and is there any transversal? ABCD are parallel. If I am drawing like this, ABCD are parallel, and if this one as a transversal I am taking, then this angle and this angle will be same. All right. Okay. So angle ABP is equals to angle, what was the name? This was P, this was Q. Okay. The blue triangle is having angle D same. So QDC. Okay. These two angles are same. Again, alternate interior angle. What else is same? We can see 90° over here and we can see 90° over here also. So 190°, 90° is common in both the triangle. So we are having angle APB is equals to angle QCD, both 90°. That is given in the question itself. Now let's see which criteria is getting fulfilled. Now as I said, for checking the criteria, just get back to your triangle, any one of the triangle, and check which criteria is getting fulfilled. So we have used this angle. We have also used this angle. Okay, I'm writing it here. And we have used this side. So which criteria is getting fulfilled over here? Anyone? From our list, which criteria is getting fulfilled? Angle, angle, side, angle, angle, side, angle, angle, side. Can you see? So from angle, angle, side congruency criteria, we can say these two triangles are congruent with each other. And hence we will be getting the second part also. Automatically we will be getting the second part, that is AP and CQ. AP from here, CQ from there will be saved by CPCT. Got it? Let's move to the next question.
Ma'am, can you go back to the previous question?
Yeah. Is it okay?
Yes, ma'am, done.
Okay, let's move to the next question. In triangle ABC and triangle DEF, AB is equals to DE. AB is parallel to DE. BC is equals to EF. And BC is parallel to EF. Vertices A, B, C are joined to vertices D, E, F respectively, show that first thing first, quadrilateral ABED is a parallelogram. Next one, quadrilateral BEFC is a parallelogram. Next, quadrilateral. Okay, the next one is AD is parallel to CF and AD is equals to CF. Next, quadrilateral ACFT is a parallelogram. AC is equals to DF, and sixth part is triangle ABC is congruent with triangle DEF. Let's draw the figure and let's try to understand what exactly. Figure is already given, so no need to worry about the figure. Okay, let me draw it. Okay, this is what the figure is given. Now let me mark the information which is given. A lot of information is there. That is AB is equals to DE. AB is equals to DE. Okay, this green side and that green side are of same length. Now AB is parallel to D. Okay, so for parallel we generally draw like mark with an arrow. So this and that is parallel also. AB and DE. BC is equals to EF. BC is equals to EF, and both are parallel also. Yeah, both are parallel also. Yeah. So both the green line are equal and parallel. Both the black line are equal and parallel. What we have to prove for the first part? Quadrilateral ABED is a parallelogram. Quadrilateral ABED, it's a parallelogram. We have to prove that this quadrilateral ABED, this is a parallelogram. We don't have to do anything over here. It's clearly given that opposite sides are parallel and equal. On the basis of that only we can say it's a parallelogram. Okay. So no other data is required. We can say since AB is parallel to D and AB is equals to D, therefore ABED is a parallelogram. Opposite side are parallel and equal. One of the opposite side is parallel and equal, and hence that is only justify that it's a parallelogram. We are done with part 1. What about part 2? Quadrilateral BEFC is a parallelogram. So where is quadrilateral BEFC? B, E, this is what we are having, the quadrilateral BEFC. It's a parallelogram. Yes, it's a parallelogram. Why? Because both the black sides are parallel and equal. No other information is needed to justify that it's a parallelogram. Already it is given in the question itself that BC is parallel to EF and BC is equals to EF. Therefore, BCEF is a parallelogram. Next, part 3 says AD is parallel to CF and AD is equals to CF. AD, where is AD? Here is AD. Is parallel to CF. This is CF. And AD is equals to CF. Okay. So now only we have proved. Now only we have proved in the first part. Let's see first and second part is going to help us for that or not. So in the first part we are saying ABED is a parallelogram. ABED, it's a parallelogram where AB is parallel to ED and AB is equals to ED. Other two opposite side will also be parallel and equal. Since we have already declared that it's a parallelogram ABED, so we can say AD will be parallel to BE since it's a parallelogram. AD will also be equals to BE since it's a parallelogram. That is the information we are getting from part 1. Because we have already declared that it's a parallelogram, other two opposite side will also be parallel and will be equals to each other. Let's move to the next one. From here, what can we say? BCEF. BCEF, we are saying it's a parallelogram where BC and EF already parallel and equal. So other two opposite side will also be parallel and equal. That is BE must be parallel to CF and BE must be equals to CF. Other two opposite side of this parallelogram will also be parallel and equal. Now from equation 1 and equation 2, if you will compare, we can say that AD, BE, CF all are parallel from 1 and 2. And what else we can say? We can also say AD, BE, CF all are of same length. AD, BE, CF all are parallel. AD, BE, CF all are of same length. What we have wanted to prove in the third part? AD is parallel to CF, AD is equals to CF. Can you see already we have proved here that AD is parallel to CF and AD is equals to CF. How we got it? From the first and second equation. How we got the first and second equation? Just by listing down the other condition of the parallelogram. Since we have already proved that it's a parallelogram, so the other information, that is the other two opposite side, will also be parallel and equal. From there only we ended up getting that all will be parallel, this all will be equal, and hence we ended up proving the third part. Okay, let's move to the fourth part. That quadrilateral ACFD is also a parallelogram. ACFD. ACFD. It's a parallelogram. Now only we are saying in the third part that AD is parallel to CF. This AD and CF are parallel, and in the third part we have also proved that AD and CF are of same length. So from 3 only we can say that it's a parallelogram. Let's write it. For part 4 we can say since AD is parallel to CF and AD is equals to CF, therefore ADCF is a parallelogram. We are done with part 4 as well. Let's see part 5 and part 6. Part 5 says AC is equals to DF. Obviously, since it's a parallelogram, ADCF is a parallelogram. Focus on ADCF. Already it is painted with blue color. ADCF. It's a parallelogram. Already we have proof for part 4. Now part 5 is saying show that AC and DF are same. Obviously, AC and DF has to be same since it's the opposite side of a parallelogram. Let's write it. Therefore, AC will be equals to DF. Since ADCF is a parallelogram, therefore AC and DF will be same because opposite sides of parallelogram are also equals with each other. Next, part 6. It says that ABC is congruent with DEF. ABC, triangle ABC, let me mark it. This green triangle and this green triangle are congruent triangle. That's what we have to prove here. How we will be doing so? So all the information, whatever we are having in hand from the very beginning, we will be collecting it and we will be checking that what we are like which sides are same, which angles are same. So no angle can, I believe, will be needed. This black side, that black side is same. So we can see BC and EF is same from where it was given in the question itself. Now arrow 1, you can see arrow 1 there also you can see. So that was also given in the question itself, that A, B and D, E are same. That was given in the question itself. Two side we have got. If we will be getting one more side, that will help us. So the third side, AC and DF, already we have proved in part 5. So we can say AC and DF are also same, proved in previous part. And therefore by side congruency, this triangle and that triangle are congruent with each other. Is it clear? Any doubt?
No,
Let's
ma'am.
take the next question. Now the last question, that is question number 12. Here we are having, I'm just drawing the figure. Okay, this much figure is already given. This much. It says that ABCD is a trapezium. What is the property of trapezium? Opposite side must be parallel with each other and the opposite sides are known as bases of the trapezium. Here one more condition is given, that is AD is equals to BC. These two sides are of same length. This one and this one are of same length. That is already given in the question. What we wanted to prove here, we want to prove that, show that angle A is equals to angle B. Second, angle C is equals to angle D. Third, diagonal AC is equals to diagonal BD. These are the three parts which we need to prove over here. For proving these parts, we need to do one construction over here. So we will be drawing like this. Okay, we will do one construction like this. We will say, let's say this is CE. Now we are saying CE is parallel to AD. We have done the construction in such a way that CE is parallel to AD. This construction we have done by ourselves to prove whatever is asking in the question. Okay. Now these two are parallel with each other. CE and AD are parallel with each other. That's what we have drawn. Can we say over here that since AB is parallel to CD, because it's a trapezium and that was also given in the question, AB parallel to CD. Now when we will extend this AB, this AE will also be parallel to CD. Do you know that when we will stretch a parallel line, still it will be parallel. When we will reduce the parallel line, will erase some part of it, it will be parallel. So let me show you with the example. So we are saying, when we are having one line like this is A, B, let's say here D is there. Okay, here we are
Here
having,
we are having
why it's
why
echoing,
it's echoing.
just a moment. Yeah, now it's not. So I am saying, if AB and PQ are parallel line, then if you will erase some part of AB, earlier it was parallel. Okay, let me write that. So earlier AB AB and PQ was parallel with each other. Now, even if you will remove some part of AB, just like this one, still AD will be parallel to PQ. Now, if you will extend this PQ, just like this, you are extending it and you are giving it a name R. Okay. Still, PR will be parallel to AD. So what I want to say from here, that if you will stretch a parallel line, if two lines are parallel, and if you are going to stretch any one of the line, still it will be parallel to the other line. If you are going to remove some part of the a part of one of the line, still it will be parallel to the other line. Okay. So this concept we are going to use in our question also. Let's see how. So here what we were having, AB is parallel to CD. We are saying since we are stretching the side AB, that is AE will also be parallel to CD. Okay. Now what are we having in hand? So here opposite sides are parallel. We have seen that AE is parallel to CD, and the other side we have done the construction in such a way that AD is parallel to CE. Therefore, A, E, C, D is a parallelogram, right? It's a parallelogram. Now we have proved that it's a parallelogram, then opposite side will be equal with each other. Okay, opposite side will also be equal with each other. So since it's a parallelogram, we have proved that this one and this one will be same length, and this one and this one will be of same length. Let's write it. AE will be equals to CD and AD will be equals to CE. These are the condition which we got after proving that it's a parallelogram. Okay. Now we know AD is equals to CE, and it is also given in the question that AD is equals to BC. So from AD is same as CE, AD is same as BC. So we can say CE and BC are same, right? From 1 and 2, CE and BC are same. Now focus on the triangle. CE and BC are same, then it's an isosceles triangle. Can we say if two sides are same, then it's an isosceles triangle? If CE and BC are same, then obviously it's an isosceles triangle where opposite angle will also be same. This angle and this angle will be same. So let's take that angle and this angle as a x. Let's take this angle as a x. This angle will also be x only. Let's write it. Angle CEB is equals to angle CBE. Angle CEB equals to angle CBE. Opposite side of isosceles triangle CBE. Okay. Let's take this two are same and this two are equals to x. Now since A, B, A, D, C, E, it was a parallelogram. Already we have proved that. We have proved that AECD is a parallelogram. In the first place only we have done that. Can we say angle A plus angle E will be 180 degree? Adjacent angle of a parallelogram are supplementary with each other, right? Let's do it. Since AECB CD is a parallelogram, From here angle A and from there angle E will be 180 degree. Adjacent angle of a parallelogram are supplementary with each other. Adjacent angle of parallelogram are supplementary with each other. Here we have assumed that angle E is x. So angle A will be 180 minus x. Okay. Now what about this angle? This angle. So we know this two are linear pair. This x and this one will be the linear pair. We can write it over here that angle CBE plus angle CBA is equals to 180 degree. Why? Because it's a linear pair. Okay. We have already assumed that CBE is equals to x. Angle CBA is equals to 180 degree. So therefore CBA we will get as 180 minus x. Why we are doing so? You can see the first part it was asking A is equals to B and only the trapezium was given in the figure. This is A, this is B, this is C, this is D. We wanted to prove that A and B are same. And now B angle we got 180 minus x. Angle A also we have already got 180 minus x only. So that's why we can say angle B and angle A are same. Let me summarize the whole thing because it was quite different. So we were having this trapezium A, B, C, D. We wanted to prove angle A and B are same. Okay, what is given over here? It is given that AB is parallel to CD and it is also given that AD is equals to BC. Here we have done one construction by ourselves. We have just done stretch this side like this and like this. And we are saying that this is E and we are saying that CE is parallel to AD. We have done the construction in such a way. Now we were able to prove that AECD is a parallelogram easily because opposite sides are parallel. Both the opposite sides are parallel, hence it's a parallelogram. Now since it's a parallelogram, here opposite side must be equal with each other. Okay. So since it's a parallelogram, this side will be equals to this side and this side will be equals to this side. So if double line, this AD and CE are equal, and it was given in the question itself that AD and BC are equal. So from here we got one isosceles triangle, that is BC and CE are equal. BC, if you will focus on the triangle, this triangle, here BC side and CE side we got same. Hence we got opposite angle also same. After getting opposite angle as a same, what we are saying, we want to prove that angle A is equals to angle B. So what we are saying, we wanted to prove this blue angle is same. So we are saying this is x, this is x. So if this is x, this will be 180 minus x. And if this is x, this will be 180 minus x because it's a parallelogram. The total complete was a parallelogram where the adjacent side sum has to be 180 degree. And on the basis of that, we are saying if that is x, this will be 180 minus x. This will be 180 minus x and hence A and B are same. Is it clear to both of you?
Yes, ma'am.
Okay. So let me check the other part. Okay. We also have to prove here this angle and this angle are same. Okay. So what we can do over here, we can just take the, we can say this is 180 minus x. So this will also be, we can find it by taking the help of the condition of parallelogram. Let's see whether it is helping us or not. So angle D, I am saying again adjacent angle A and D has to be supplementary since it's a parallelogram. A and D will be supplementary with each other. So angle A plus angle D has to be 180 degree. If A is only 180 minus x, D will be, angle D will be 180 minus 180 plus x. So angle D will be only x. We got this as a x. All right. Now we have to find, we have to check what is angle C. Angle C doesn't mean that total complete black angle. Angle C means this angle only. This angle. Because previously we were not having this construction part. We were having only the trapezium. So if it is asking us to prove that angle C and D are same, that means it is just asking about the trapezium part, not the outside construction or anything. Okay. So if those two angles are x, we can say this one will be 180 minus 2x, right? Angle sum property of this green triangle will give us what? X plus angle C is equals to 180. So angle C will be 180 minus 2x. For green triangle, yes or no? In triangle BEC, in triangle BEC, we got angle C as a 180 minus x. We have to find this part of C. Okay, again linear pair if we will be taking. So we can say that if that is angle ECB plus angle BCD, it's a linear pair and that is 180 degree. That's what we can say. Okay, no, that is not linear pair. Sorry, it's not linear pair because you can see the angles are different. One thing we can take over here, that this complete is 180 minus 2x. We have to find this angle. What can be taken over here? What is the next part? We have to prove C is equals to D, and we also have to prove one more part is left. I believe I'll be taking this two part